Hello everyone, today I'm making this new movie for you to cover the explanation for chapter 2. And yes, up to now we already finished chapter 1, and I expected some of you or most of you got the content from chapter 1 or understood the content from chapter 1. But again, if some of you still don't get the point, not clear regarding some points in chapter 1, yes, you can ask. We can discuss what you raise, the question or concern for chapter 1. But right now, okay, just move to chapter 2. This is chapter 2. The title of chapter 2 is Describing Data. So in order to describe data, we use some statistical techniques or statistical methods such as frequency tables, frequency distribution tables, and graphic presentation. So chapter 2, the title chapter 2, Describing Data, by using some techniques, statistical techniques or statistical methods. For example, yet again, frequency tables, frequency distributions table, and graphic presentation. This is the objective points or the goal points that all of you need to get the content after you complete this chapter. And again, after you complete this chapter, try to understand or try to answer by your own, or you can ask question for you, and you try to remember what you have memorized from, or what you have remembered from chapter 2. And again, when you finish chapter 2, you need to go to this slide again and check yourself. Okay. Point 1 of our goals: make frequency table for a set of data or called data set. So when you complete this chapter, the first point that you need to do or you can do is how to make frequency table. Okay, how to make frequency table from using a data set. For example, you have data set. By using the data set, how to make frequency tables. Okay, so a frequency table or frequency tables, it depends on. But the first one, how to make it by using data set that you have. Second point, organizing data into bar chart. So when you have data set, and for example you don't want to make a table but you make a graphic, how to use data set in order to make bar chart. Okay, when you make bar chart, for example, when you got bar chart, when you already finished making bar chart coming, how to explain information on this bar chart. Okay, but the second point objective, how to organize data into bar chart or data set into a bar chart. The third point, present a data set into a pie chart. That means how to use pie chart, how to make pie chart from using our data set. And when pie chart coming, or when you complete doing making pie chart, how to present this pie chart. It means that how to interpret, how to say something about this pie chart that you already made from using data. 4. Create a frequency distribution table for a data set. So the first point, it means that you have a data set. Based on the data set, you need to make you need to create a frequency distribution table. The first point, frequency table. But the first point, frequency distribution table. What is the difference between these two tables? Okay, maybe now you have question, but when you complete this chapter, you will not have question. You will not have question anymore because you already understood when you completed. But right now you may have question. What the difference between frequency table and frequency distribution table? Okay, so keep the question in your mind and then try to understand when we go there. If when we go there, or if we already go there but you still not understand, okay, you can contact us or you can contact me. The fifth one, understand a relative frequency distribution. Relative frequency distribution. Okay, what does it mean? It means understand. You need to understand what does it mean. Relative frequency distribution. Sixth point, present data from frequency distribution table into histogram or frequency polygon. Histogram or polygon. Okay, so what are they? Histogram, frequency, polygon. Okay, now you can put question, but keep your question to check when we go this point. 7. Construct and interpret a cumulative frequency distribution table. Cumulative frequency distribution table. Okay, so you will understand when we do go to this point. What does it mean, cumulative? Okay, so these are the points that you need to run. Yes, these are the points that we need to run for chapter 2. But I may make 2 or 3 movies in order to cover this chapter 2, because if I make one movie is too long. Okay, so let's go. This is the first introduction. When we're talking about statistics, remember that from chapter 1, when we're talking about statistics, we're talking about data. We learn about data. We study data because data tell us something. So, who remember the definition of data from chapter 1? Who remember? What does it mean, data? What does it mean, data? Okay. Yes. If you are not remember, or if some of you still not remember, okay, we go to chapter 1 and 1. This is data from chapter 1. Data are the facts or figures collected, analyzed, and summarized for presentation and interpretation. Data are the facts or the figure of something that we want to study, that we want to know. That's why if you want to study, if you want to know, you need to collect data from what you want to study. And then when you collect data, you need to analyze. When you analyze, the result coming, you need to present it, you need to conclude it, you need to say something about it. So this is data. And this is the way that we use in order to collect data. This is from chapter 1. I just recall primary data collection, or we call, I can say that direct data collection, direct method to collect the data, indirect method to collect the data. So direct, that means you go to meet them, you go to get them directly. Indirect, that means you're not going to meet them or to get them directly, but you can get that they are the information, the data from the other sources, not directly. Okay, that one. Data in raw form are usually not easy to use for decision making. Yes, sure. Data that you just get it from where or the source that you get is not clean, it's not organized yet. It's a raw form, it's a messy form. That's why you cannot use raw data or messy data or raw form data or figure data in order to make decision, because it is not telling you a full clear. Sometimes something missing, sometimes something is messy. So you need to make it in order, or to make it clean, or to make it clear in order to use this one. That's why data in raw form normally not easy to use. So don't use raw form data to make plan, to make decision. Data must be described in various forms for being easy to understand, and easy to understand the situation that data represents, that data want to tell us. Because when talking about data, data is raw form. Data is a fact or figure about something that we want to study, that we want to understand, or the situation, the raw fact or the raw form of situation that we want to study. That's why data must be described. Data must be used in order to tell, to describe various form of, for being easy to understand the situation that data describe. Indeed, an effective presentation of the data often quickly reveals important features. Okay? Important features such as their range. Range is like coverage or scope, okay, or limitation. Degree of symmetry. Symmetry, that means like yes, two things are symmetry. That means one thing, not two things. One thing is symmetry. That means one part, the right part or the left hand part must be the same size, the same or similar size, similar shape. That's why it is symmetry. So degree of symmetry, that means from compared to the middle, the lower side and the bigger side, are they similar shape? Are they similar picture? So data, we have for example, we have a data set. That's why you need to clarify by setting a middle point. From middle point to the other side and middle point to the other side should be similar to each other. If they are similar to each other, that means the degree of symmetry tend to be 100%. But if they are not similar, the degree of symmetry tend to be lower and lower. How concentrated or spread out they are. That means when we have a data set, we have data item. A data item is element or is a member of the data set. For example, I can say that your class have, for example, your class have 60 students. 60 students in this class in the data set, but one student to the other one. This is one student we call data item. The other student we call the other data item. Okay, that's why how are they? Are they, that mean or how they are? Not are they? How they are? They are, that mean how students are closer to each other, concentrate. For example, you can imagine where we are in the physical classroom, not online class. So you sit on the chair or sit. I on the front of the class. I may be standing explaining something. Some students sit on the right hand side of me. Some students sit the left hand side. Some students sit the back closer to me. Some students sit sit the front row closer to me, and some students sit the back row far away from me. If all of you sit everywhere in the class, so one student to another student tend to be far away from each other. That's why this is called spread out. But if all of you tend to sit closer to each other, okay, that's why you tend to be concentrated. That's why data items sometimes concentrated or they are spread. How spread they are, how concentrated they are between data item from one to the other one. Where they are concentrated. If they are, for example, if some of you sit closer to each other, where all of you or most of you sit closer to each other, in the middle location of the class, or in the area closer to the window, or in area closer to my teacher's table, or in the area that closer to the door. That's why if you sit closer to each other, where you sit, most of you sit closer to each other, in the central of the class location, closer to window, closer to the teacher's table, or closer to the door. That's why we want to know. But in terms of data set, we don't have many locations like this one. We just have maybe 3 locations: lower value location, middle value location, and higher value location. Okay, in terms of data set. In this chapter, we will be concerned with descriptive statistic techniques. Okay, from a previous chapter, we were looking at 2 types of statistics: descriptive statistics, inferential statistics. So, chapter 2, we will use descriptive statistics techniques or methods, both by using tabular that mean table, and graphic that mean graph, in order to present our data set. So in chapter 2, we will use descriptive statistics techniques or methods by using tables and graphics in order to present our data. Okay, first one, constructing a frequency table by using qualitative data. From chapter 1, we are looking at 2 types of data, right? Qualitative data and quantitative data. Okay, maybe I'm not going back to chapter 1 again, like I showed you in the earlier. That's why you need to remember by your own what the difference between qualitative data and quantitative data. But in this case, we will use qualitative data in order to make frequency table. And maybe I pose you the question: what does it mean, qualitative data? Okay. Frequency table is a technique. It's a statistical technique or statistical method that we use in order to classify quantitative data into mutually exclusive classes or into mutually exclusive groups. Okay, frequency table is a statistical technique or statistical method that we use in order to classify qualitative data into mutually exclusive classes or mutually exclusive groups, showing the numbers of observation in each class or each group. Observation, you can call observation or you can call data item. In data set, like I mentioned in the earlier example, your class, suppose your class has 60 students. each student, one student, I can call one student as data item or one observation. Why? Because if I want to understand all 60 students, I need to observe one by one. That's why the one that I observe, I get observation. I observe data item. That's why each student I can call data item or I can call observation. Okay, so frequency table is a statistical technique or statistical method that we use in order to group or in order to classify of qualitative data into mutually exclusive classes or groups that showing the number of observation, number of data item in each class or in each group. For example, maybe I'm not going to this one, I just going to your class. Okay, for example, your class 60 students are you. If I subject to study about sex or gender, 60 students are you. Some of you male, some of you are female. So if I classify or if I group students into two groups, because in terms of sex and in terms of gender we have only two, there's no three, only two, male group and female group, or male class or female class. That's why among 60 students are you, after I classify or after I grouping, I have only two groups. One is male and one is female. Okay, so if I select one student coming, and after selecting I see that he must go to male group. If he is, that means going to male group, he is exclude from female group. Okay, exclude from female group. If I select one student and he must go to male group. If he must go to male group, he is excluded from female group. That's why it is mutually exclusive classes. Male class, female class. If you are male, you are go to male group and you are excluded from female. If you are female, you are classified into female group, you are excluded from male. That's why mutually like exclude each other. Okay, so mutually exclusive is like exclude each other. You are male, go to male, you are excluded from female. If you are female, you go to female group, you are excluded from male. That's why male and female exclude each other from their own respective group. Okay, their respective group is male go to male, female go to female. Female exclude from male, male exclude from female. So this is the meaning of mutually exclusive. I will say something a bit when we go there. For example, Applewood Auto Group has 4 dealers, 4 dealership. Dealership that means shops selling or sellers, such as Tynestar 1, Olean 2, Sheffield 3, and Kent 4. That's why Applewood producing car, but they are producer, they are not a seller. So after car producing from Applewood, those cars sent to 4 sellers. No, so normally these 4 sellers not located in the same city or the same province. Okay. Catherine is a senior manager team. Catherine last month collected sales data from those 4 dealers. After collected data from those 4 dealers, she found that last month those 4 dealers could sell total number of cars 180. So Catherine was a senior manager team, collected data from those 4 sellers last month, and she found that those 4 sellers could sell together up to 180 cars. she summarized this data into frequency table that categorized by each location for for purpose or for benefit of easier understanding and decision making. Okay, so she will summarize the data that collect from those 4 dealers into frequency table categorized by each location, each dealer, because normally this dealer not located in the same area or the same province, the same city. They are located far away from each other, different city, different province, different state. Okay, so she make frequency table by using data set from those 4 dealers. Those 4 dealers look at different location. So can look at from maybe, let's say, city, look at one city, Olean the other city, Sheffield or the other city, Tynestar or the other city. That's why she make frequency table like this one and categorized by or classified by or grouped by dealers. So there are 4 dealers. That's why she arranged into the 4. This is the number of car that she collected from each dealer. Ken could sell 50 car last month. Olean could sell 40 car last month. Sheffield could sell 45 car last month. Tynestar could sell 43 car last month. Together, she Catherine, she understood that 180 from those dealers. Okay, this is we call frequency table. Frequency table. Frequency table. This is frequency. This is a object that we study. This is something that we want to study. Catherine want to understand the ability to sell a car last month from these 4 dealers. That's why this is what she wanted to study. This is a frequency that each item that she wanted to understand. We may want to know the percentage. This is not percentage, this is number. We may want to know the percentage of total cars sold at each of the 4 locations. To do what? To do that, we convert a frequency table into a relative frequency table. What does it mean, relative? Maybe some of you still remember ratio. Relative in this case, similar meaning to ratio. Something over something. One number over one number. But in this case, not one number over one number like a ratio. It's specifically, more specifically than ratio, we have a specific meaning. Okay, look at together. See, something over something, or some number over some number is ratio. But if we're talking about relative, number over number. What number? Number from frequency. The item that we study, it has own frequency. Item that we study, it has own frequency. It has own frequency. It has own frequency. That's why 4 items that we study, or 4 locations that we study, or 4 dealers that we study must have 4 frequency. Okay, this is 1 4 frequency. Each dealer has its own frequency. So, in order to get relative frequency table, you need to take frequency from each item divided or over total frequency. Okay, remember ratio one number over one number, something over something. But relative is more specifically because number over total frequency. Each frequency over total frequency. Specifically is over total. You cannot set 52 over 40, 40 over 43, something cannot be this one. Cannot be this one. You need to, in order to make relative frequency, you need to take frequency from each item divided by total frequency, like this one. Okay, so this is, you can see, maybe yes, a little bit strange, but don't feel strange. This is 0.289. What does it mean? It means 0.289, but normally they cut 0 because 0 is nothing. That's why when we're talking about 0.5, let's say for example 0.5, they just say 0.5. 0.70, they just say 70. They don't say 0, okay? Because 0 is nothing. That's why in this case, not 289, but 0.289. How to get 0.289 or 0.289? Because this is a relative frequency from the first item. That's why in order to get relative frequency from the first item, you need to take frequency of the first item divided by total frequency. 0.222 this is second item. That's why you need to take frequency from second item divided by overall total frequency. Again, 250 or 0.250 this is from third item or third location or third dealer. That's why you need to take the third frequency dealer divided by total. Okay, so this is we call decimal number, but not percentage. How to get percentage? In order to get percentage, you need to multiply by 100. Okay, if you multiply by 100, this should be 28.9%, 22.2%, 25%, 23.9%. Okay, so this is we call decimal number, not percentage number. But in order to get percentage number, just multiply by 100. So this is table 2. Table 2, relative frequency table of workhorse or car sold by tab or dealer last month at Uphold Auto Group. Okay, so now you look at, we already see how to make the frequency distribution. In order to make frequency distribution, you need a data set. The data set that you use is qualitative data set. And once again, I'm not saying again about definition qualitative data set. You need to find by your own, or you need to remember by your own. Okay. So table 2.1, because chapter 2, table 1. Table 2.1 is frequency table. Table 2.2 is relative frequency table. This is relative. We have 3 columns. Column 1 is item that we study. Column 2 is frequency of each item that we study. So based on these 2 columns, we call frequency table. But if you make the other column by taking each frequency of each item divided by total, we call relative frequency. Okay, we call relative frequency. So table 2.2 is relative frequency table. I think that you got the point. Okay, if you not, okay, contact me. Graphic presentation of a frequency table. So in order to make presentation, you need to use graphic or graph. So what graph that we can use for frequency table? Bar chart. Bar chart. Bar chart is a graph that shows qualitative groups or classes on horizontal. What is horizontal? Maybe you know X and Y, graph X and Y. This is vertical, this is horizontal. Normally when you study mathematics, vertical is 0y, horizontal 0x. That's why this is horizontal. Okay, horizontal axis is like this side, 0x or 0x. And the class frequency on vertical axis. This vertical axis is like 0 and y. Okay, maybe you can ask me, what is qualitative classes? What is class frequency? Okay, go back to this one. What is qualitative classes? This is qualitative classes. There are 4 locations, 4 dealers, or 4 classes of dealers. This is frequency or qualitative frequency. That's why when you make a presentation by using bar chart, qualitative data or classes or group take as a horizontal. Class frequency take as vertical. Okay, how does it look like? We go to next slide. We can see the class frequency are proportional to the height of the bar chart. You can see it on page 25. Maybe 25 textbook. Bar chart can be used for presenting in different forms, such as a simple bar chart, a clustered bar chart, a stacked bar chart, So in this case, bar chart, you have 3 types of bar chart in order to make graphic presentation by using qualitative data or by using data from frequency table. The first, simple bar chart. Second, cluster bar chart. And third, stacked bar chart. Okay, this is the simple bar chart that we use data from 4 dealers. Who are 4 dealers? Gain, Orient, Sheffield, and Star. So this is we call horizontal axis. Mathematics we call 0x. This is vertical axis. In mathematics we call 0y. That's why item that we study we put on horizontal. The frequency of each item that we study we put on vertical. The highest bar represents the more frequency, the more number. The lowest bar represents the low frequency or the low number. Okay, so this is simple bar chart. Number of workers sold last month at Applewood Auto Groups by location. Gain, Orient, Sheffield, and Star. Okay, by looking this one, we can see that Gain could sell more than 50 cars. Orient could sell only 40. Sheffield could sell maybe 45 because it's a middle. How about Star? Maybe could say less than the middle of 40 of middle number between 40 and 50. That's why less than 25. Sorry, less than 45, not 25. So Star must be higher than 40 but less than 25. Based on the location, I can say that maybe 43 or 42, something like this. So by looking at this chart, I can see that Gain could the good dealer. Last month, Gain did the good play because Gain could sell more cars than the others. Orient last month did not really good, could sell lower number of cars. Okay, this is based on looking for this one. It's easy for me to see which one is more achievement, which one is less achievement. Pie chart. This is bar chart, simple bar chart. Pie chart. Pie chart is used to display the percentage of relative frequency. Okay, table 2.2 is relative frequency table. That's why we use pie chart for those tables. Is used to display percentage of relative frequency of each category, each class, or each group. Represents of the total number of frequencies by partitioning or separating a circle into sections, into parts. Okay, so maybe we're not looking at the previous one, table 2.2, but we have the other table, table 2.3. Table 2.3 show us the Ohio State Lottery expense. Lottery, you know lottery, right? Ohio State Lottery expense in 2009. So Ohio State Lottery expense, there are four expenses, four type expenses. One, prizes, education, training, something like this, bonus, and the other expense. Okay, so this is a four item or expense, the four types of expense that we want to study from Ohio State Lottery expenses. And each type of expense, they have their own spending. Okay, price, they spend 1,000, almost 1,500 million. Education, training is about 700 million. Bonuses is about 150 million. The other expense is about 124 million. This is based on these two items. Based on these two columns, we can call frequency table. But if you extend the other column as a percentage, this is we call relative frequency table. Maybe I'm not saying again why we get 60, why we got 29, why we got 6, why we got 5. Okay, based on this relative frequency or percentage, we can draw a pie chart. Pie chart is a circle chart. Okay, pie chart is a circle chart. That first you need to, when you draw a circle, I think it's the best way to divide a circle by 4 sections. Every section consists 25%, 25%, 25%, 25%. Maybe 25% is not easy to scale. It's not easy to put like at the part like this one, a part like this. That's why try to look at a little bit more detail. That's why not only 25%, but they look at maybe among 25% here. I divide it by how many parts? 1, 2, 3, 4. 1, 2, 3, 4, 5. 5 parts. But 1, 2, 3, 4, 5. So 5 parts. So this is 25. I allocate into the other 5 parts. That means each part represents 5%. 5%, 25. 5%, 25. 5%, 25, 25. That's why it's easy to me to count. For example, 60. How to allocate 60 parts among this circle? That's why I know that this is 25, this is 50. Okay, half of the circle is 50 share, but we have 60. That's why I need more 10. So I know that a small part here 5. That's why I need 2 small parts, 1 and 2. So I can select here up to here. This is 60% price. And how about 29? 29, I'm not starting from 0 again, because 0 from 60 is already belong to price. That's why I need to continue drawing. That's why I will start from 60. 60 to this one is about 30. Okay, 60 to this one, 65, 70, 75, 80, 85, 90. But no, we don't get 90. That's why I got maybe a little bit lower than this one. This is 29. Okay, but how about total? Not 29. Total is 60 plus 29 is 90. So 89, not 90. 89. 6. 6. It should be 5 plus 1. This is 1. I need other 5. But I know that one part is 5. That's 5. This is 6. How about 5 plus 1? 5 plus 1 is the last one. That's why, because we have 4 items, 1, 2, 3, 4, 5. That's why pie chart will classify or will split into or partition into 4. 1, 2, 3, 4. Okay. Or you can put a label, price, education, commission, bonus, or other expense. operating expense. Okay, like this one. So this is a pie chart. Pie chart is used for presenting the percentage only. Okay, because the whole circle here is 100%. It doesn't matter a big circle like this one or a small circle like this one. It's still 100%. Okay. So now we have pie chart. We have bar chart. Any question from pie chart and bar chart? If you have, okay, contact me or drop question to me.